So in all of the last videos, we were working with expressions and simplifying expressions. So combining like values and putting them together. In this video, what we're doing is we're solving equations. So what's going to start showing up are these equal signs. So what we want to do is solve, meaning we want to find the value that works for our variable that balances this equation. So like in this first piece, we're thinking, what can we add to in order to get 6 out? Now, with this one, might be thinking of the answer already. However, we want to have a process to go through with these. So the key is that we need to keep the equation balanced as we go through this. So that equal sign is important. And the idea is that whatever we do to one side of the equation, we have to do the same exact thing to the other side of the equation. And that'll maintain balance of these two sides being equal to each other. So when we have our variable, and I'm just going to highlight it here so I know where my focus is. With my variable, I want to get that all alone on one side of the equation. So the idea being, right now we're adding 2 onto it, and I want to stop that. I basically want to get rid of that. But I can't just erase it. If I just take away that 2, it's not balanced. So whatever I do to this side, I need to do to this side as well. So what I'm going to do is rewrite this a little bit. I'm going to leave a little more space here. X plus 2 and then equals 6. So here where I'm adding on 2, if I want to undo that operation, what I would do is the opposite of addition is subtraction, and then I'm going to use that same value. So now what's happening over here is if I have plus 2 minus 2, that just turns into 0, which is perfect because then all that I'll have on that left-hand side of the equation is just x, and then equals the right-hand side of the equation. However, I missed a little step back here because I subtracted 2 from this left-hand side of the equation, and whatever I do on that left-hand side, I must do on this right-hand side as well. So over here, what I'm getting is 6 minus 2, which in terms of calculation is just 4. And that would be our final answer. Now, what's nice about these is that we can actually check our answer. I'm going to go ahead and check. And in order to check, we're going to substitute that 4 back in. So where I have x plus 2 equals 6, what I'm going to do is where I had x, I'm going to make parentheses, and I'm going to go plus 2 equals 6. Now where I have the parentheses, I'm going to put 4 in there. So that's a 4 plus 2, which is 6. And then we're saying that that equals 6, which is a true statement. So that checks our answer for us that it does in fact work, that 4 plus 2 is in fact equal to 6. So this is one way of going about writing it. However, another form you might see, and this is most often the form that I use, if we have this x plus 2 equals 6, then again, I'm focusing on that value of x, and I see I'm adding 2. And what I can do is recognize there that I need to subtract 2, and whatever I do to the left-hand side of the equation, I do to the right-hand side. Then what this will do is I'll see my 0 right there with the plus 2 minus 2, which will leave me with x, and then 6 minus 2 equals 4. It's the same exact thing that I did up above there. It's just kind of more of a vertical format of having the minus 2 kind of working downward instead of in one line. However, it's exactly the same. So if you have a method that you've used before, use whatever you're most comfortable with. I typically write in this more vertical form, but this original way works as well. All right, so here, let's say we have a negative 4 plus x equals 5. And what I want to do is get x all alone on one side of the equation. And x should be positive. It's kind of like what's ending up here is there's like this positive 1 in front of x right there. So with that, when I'm solving, I want to make sure I have positive 1 at the end there, which is already what we have here. With these one-step equations that we're showing here, we're going to have this kind of positive 1 right there. So what I need to get rid of is this negative 4 that's adding on to it. So if I want to get rid of a -4, or it's kind of like subtraction of 4, then what I would do is add 4. So a -4 plus a +4, that's going to make a 0. And then whatever I do to one side, I have to do to the other. So -4 plus 4 turns into 0, and then I have my positive x equals 5 plus 4, which is 9. And then what we can do is check our answer by going, we have -4 plus x equals 5, and I'm going to go ahead and substitute 9 in. -4 plus 9, that's the same thing as 9 minus 4, which is in fact equal to 5. So it checks out, so x equals 9 is our solution. All right. Now with this one, so my variable is right there with x, but I have something multiplying on. And if it helps, you can rewrite this as 3 times x equals 27. So what we saw up above there was we saw addition with x and subtraction with x, or it's kind of addition of a negative, but it's the same idea. Now we're looking at multiplication and division. So what we saw is addition can be undone by subtraction, and subtraction, or a negative number, can be undone by addition. With multiplication, the opposite operation is division. So here I can see x is being multiplied by 3. So to undo that, what I would do is divide by 3. Because then what we would have is 3 divided by 3, which just turns into 1. So then I would just have x left over, which is exactly what we want. Only thing I need to do is, since I divided the left-hand side by 3, I need to divide the right-hand side by 3 as well. So 27 divided by 3 is equal to 9. And then what we can do is check that that actually works. So we're saying 3 times our number is equal to 27, and we're plugging in 9. 3 times 9 is in fact equal to 27. So that all works out, and x equals 9 is our solution. So if you have multiplication of a value, you would divide both sides by that value. Now, if we have division, so x is being divided by 4, to undo division, what we're going to do is multiply both sides. And what we do is multiply by the denominator. So I'd multiply by 4, multiply by 4. So what this would do is we would have really 4 times x over 4 equals 3 times 4, which is 12. And that 4 divided by 4 just cancels out into a 1. So this is going to be x equals 12. And then we could check that that actually works. So we would have 12 divided by 4, and is that equal to 3? And it is. So x equals 12 is our solution. So these are one-step equations where if something is adding on to x, you're going to use subtraction. If something is subtracting from x, you'll use addition. If something's multiplying with x, use division. If something's dividing x, use multiplication. So you want to use the opposites. When it's addition, subtraction, you're trying to create this 0 next to x. Like adding on 0 doesn't do anything. When it's multiplication, division, you're trying to create this value of 1, and that comes from dividing the same thing by itself turns into a 1, and then you would just have your x left over.